NTT is researching the technologies that will make WiGig applicable to mobile communication. With the cooperation of Docomo Team Dandelion Racing, we installed a WiGig terminal in a Formula car. The following introduces an experiment conducted under remarkably severe conditions with a combination of WiGig, a Formula car, and rain. WiGig is a wireless LAN standard in the 60 GHz band. It's for license-free, private wireless systems and can provide wireless transmission with a transmission rate of several gigabits per second. The wireless transmission range is up to several hundred meters in a line-of-sight environment. In WiGig, emitted radio waves are focused in a specific direction to increase the transmission range even when the signals are high frequency and broadband. The focused radio waves are called an antenna beam. WiGig base stations periodically sweep in all directions to capture the signal from a terminal. This function makes it possible to connect to a moving terminal. When a terminal moves across zones covered by multiple base stations, it needs to switch base stations to connect. This switching is called handover. In a private wireless system, a terminal cannot connect to multiple base stations. Even if the terminal and a base station are far apart and the wireless transmission speed is reduced, the terminal cannot hand over to a new base station until it has been disconnected from the previous one. Furthermore, it takes time to find a new base station, thus the time to switch becomes even longer. To solve this problem, NTT Access Network Service Systems Laboratories have developed the following technology. By sweeping its antenna beam, a WiGig base station can estimate the direction in which a terminal is located. It can also estimate the distance to the terminal from the round-trip time of a control signal utilizing a 1.76 GHz wideband signal. From these two pieces of information, direction and distance, the control server estimates the terminal location. When the terminal approaches a zone boundary, the control server requests the terminal to hand over to an adjacent base station. In this experiment, we used two systems of base stations and terminals and placed these alternately. In this way, even if one terminal was switching base station, the other terminal could continue to communicate. This function makes it possible to achieve uninterrupted wireless transmission even in a mobile environment. December 7th, 2021. A demonstration experiment to verify this technology was conducted on a Super Formula circuit. Two WiGig base stations were set up 150 meters apart on either side of the main straight of the Suzuka circuit. The WiGig base stations and terminals were controlled by a control server. It was rainy that day. Even so, the maximum speed of the Formula car was over 260 kilometers per hour. These conditions were a challenge for WiGig, as radio waves in the 60 GHz band are easily absorbed by water. So, was it possible to hand over successfully? Here it comes. The Formula car has passed by. And the handover has been successful. A total of 4 base stations took turns to hand over, and no interruption occurred in the wireless transmission. On the next day, December 8th, it was cloudy. On this second day of testing, we tried to upload video data recorded by a camera mounted in the car. The maximum speed was over 280 kilometers per hour on this day. It's probably true to say that this is the fastest that humans can travel on the ground. Even at this mobile speed, the recorded video data from the camera mounted in the car was uploaded instantaneously. This technology makes it possible to set up pinpoint connections with moving objects, such as cars, drones, and robots, using WiGig, and instantly transmit large amounts of data, such as high-definition video and 3D map data. Of course, this technology can be applied to 5G and 6G for mobile communication. NTT will continue to take on the challenge of achieving faster and more flexible wireless communications.